So it's an honor to introduce our first speaker, Professor John Molina. He is the current director of IMDEA Materials. He is a professor at the Technical University of Madrid, and he is the head of our micro and nanomechanics research group. So I guess we can get started with John whenever you're ready.
Okay, so welcome everybody, and we are delighted that you joined this meeting, which, if I understand your motivations, you are looking at opportunities to carry out a PhD, and we think that if you are working in materials, IMDEA Materials might be one of the best institutions where you can follow a PhD program. And what I'm going to do now is introduce you to the Institute, a very high-level presentation, just to give you information on how we are organized, what are our objectives, what type of research we carry out, so that you get to know the Institute a little bit better. The Institute is part of a network of 7 institutes that share the same corporate image. Then they are an initiative of the regional government of Madrid. We are all called IMDEA. IMDEA means Madrid Institute for Advanced Studies, and there are 7 different institutes in the region of Madrid working in different disciplines: water, nanoscience, software, energy, and the one that we are at here today, the one working in materials. Among the 7 institutes, we gather more than 1,000 researchers of 40 different nationalities, very international institutions, and working in the forefront of our disciplines. For instance, for those of you who are not familiar with the Spanish system, the Spanish system recognizes the best institutes in Spain through a seal of excellence that is called Severo Ochoa María de Maeztu, and 4 of these institutes, including ours, have had or has the seal of excellence, recognizing the excellence in our activity by the national government. Okay, in our case, we are a relatively young institution, only 18 years old, founded in 2008. And we were funded with 3 different missions, which are the pillars of our activity. The first one, and the most important one, probably, is to do excellent science in material science and engineering. We are doing fundamental research, but always oriented research with our second mission, which is to transfer the results of our activity to the society through collaboration with industry, or also through the licensing of our technology, or even the creation of spin-offs to be able to exploit the technology that we develop. And with a third mission that is also very important for us, because the only way of doing research of excellence and to transfer this to industry is to get the best people in the world working in the institute, and therefore talent attraction is also one of our missions. We want to attract to our institute the best researchers in the world working in material science and engineering. For that, we get with the help of we have the help of 2 external advisory boards that for us are very important. So we have 2 external bodies that are always advising us on the best directions to take, both at the fundamental research level through our scientific council, in which we have representatives from the best institutions in the world working in material science and engineering. You have the list there, and also an industrial advisory board that helps us with our strategy for transfer of results. And these are companies with which we have strategic relationships in our scientific activity. Among the size of the institute is relatively small. We have 172 employees, of which 150 are researchers from 25 different nationalities. It's a very international institution, and we are organized in 19 research groups. We have a very horizontal structure through which each of the research groups is composed of a number of postdoctoral and predoctoral researchers. So as you can see, currently we have 73 researchers, early stage researchers, that are carrying out their PhD with us. Of course, we are not an academic institution. These PhD students are actually enrolled in the local universities with which we have agreements so that our researchers can enroll in their PhD programs, and they are carrying out the research work linked to their PhD thesis with us. As I said, we are a very international institution. 50% of our researchers are foreign nationals, and even from the ones that are Spanish, 60% got the PhD in foreign universities. So we are not only attracting researchers from all over the world, but are also facilitating that Spanish researchers working abroad come back to work in Spain. These are the 19 research groups. You have the complete list in the webpage. I'm not going to go through all of them, but as you can see, we are working in different areas that actually are coordinated through our research program. So we have 5 different research programs in which these 19 research groups are carrying out their activities. We like to express this like a rocket that is fueled by the talent that we have in the institute, and this talent is oriented to work in novel materials discovery, in advanced manufacturing, in an integrated computational materials engineering, so simulation in silico of the design, processing, and characterization of different materials. Also a very strong program of multi-scale and in situ characterization that allow us to see and understand what properties actually control the behavior of materials under different conditions, and also a 5th program on digitalization and artificial intelligence, so data mining and artificial intelligence at the service of discovering new materials, and mainly working in 4 different sectors: transport and industry. We are going to see some examples now in materials for energy and in materials for health to improve the quality of life of the society. We have state-of-the-art research facilities. It's a pity that this meeting is online, because a visit to the institute, I think, would help you understand the type of facilities that we have to carry out the research. And as I said, it's composed of state-of-the-art equipment for processing and characterization of different types of materials. Just to give you some examples of the type of research that we carry out in the institute, in the area of transport and industry, we are working for discovering materials that can behave or operate at extreme conditions. When I say extreme conditions, I mean materials with high impact resistance, materials that can withstand very high temperatures, but also conditions of fire or irradiation for nuclear applications. Advanced metallurgy, so we design new alloys that work and operate better in different applications. We are working in many areas of electrification of transport, materials for energy storage, but also multifunctional that can fulfill structural applications, carbon materials that can substitute copper and allow the reduction of weight in transport applications, etc. Also a lot in circular economy, in the possibility of bio-based materials, and also on recycling of materials. In the area of materials for energy, working in the development of materials that are critical for batteries, that are important for the long term. New anode materials based on silicon that will increase the capacity of batteries by tenfold. Also new materials for electrodes and electrolytes in batteries that are fire resistant and fire retardant. You know what is the implication of fire in the lifetime of batteries. Also new materials for hydrogen technologies and also for catalysis. And in the area of health, applying our expertise in health applications, regenerative medicine, new implant materials, bioabsorbable structural implants that can fulfill a structural function, but then be absorbed by the body without having to have a second surgery to extract the implant, and so on. as I said, we have a very well-defined expertise worldwide in many areas at the service of this research that I was mentioning before. So we are experts in the characterization at 3D of different materials through X-ray tomography, diffraction, SEM, TEM, electron microscopy. We do a lot of in situ characterization in our instruments. So we analyze how materials deform, how they are processed at the structural level. We have capabilities at different scales to simulate the behavior of materials and to carry out virtual processing, virtual testing, and also computationally driving materials discovery. And our activity is measured in different areas, mainly through publications in the best journals in our area, but also transfer to industry through many contacts or contracts with industry, and also participation in many European projects, and also a lot of activity in the area of talent attraction through grants of the best institutions in Europe, like the ERC grants for carrying out the research. I don't want to spend much more time because I think the most important message that you can get today is from our actually alumni that have carried out their PhD with us, and they are now working either in academy or industry. So I will stop here with just this last slide because, as I said, we do transfer of knowledge, but also talent transfer, okay? And this is a slide that shows that through the 124 defended PhD theses that we have had in the institute in our history, those alumni are working in the best institutions in the world, in academy and industry, and you have the list here. Okay, if you have any questions, of course, I will be happy to answer them.
We're now going to continue with Dr. Yuyao Liu, who is an IMDEA Materials alumni and is currently Marie Sklodowska-Curie Action's MSCA postdoctoral fellow at the Royal College of Surgeons in Ireland. So, Yuyao, I will give you the floor, and whenever you're ready.
Thank you. So, hello everyone, and thanks for the invitation for the Open PhD Day. So, I am Yuyao Liu, a former PhD student in IMDEA Material Institute. So, I am Chinese. I did my PhD journey from China to Spain to IMDEA. So, today I'm going to share you some experience that I had during my 4 years PhD life. So firstly, give a short introduction about myself. So my name is Yuyao Liu, and now I am a Marie Curie postdoc fellow in Royal College of Surgeons in Ireland. So I work in the Department of Anatomy and Regenerative Medicine. So I did my bachelor and master in China, and then I decided to move to Spain to have my PhD working in materials engineering, mainly on biomaterials. So I got my degree from Polytechnical University of Madrid, and also got the trained in IMDEA Material Institute. So my research field are focusing on 3D printed biodegradable polymer scaffolds and osteochondral tissue engineering. So in IMDEA, I work in two groups. I work in biochemical mechanics of materials, led by Professor Javier Llorca, and biometals, coatings, and devices group, led by Dr. Monica Echeverry-Roden. So here I have so many colleagues in both groups and have a very good life during my 4 years of PhD. So give a short introduction about my PhD topic. I work in the biomaterials and tissue engineering. So my topic is mainly on the designing of scaffolds for osteochondral tissue engineering. So I develop some biodegradable polymer scaffolds with tailored mechanical properties and degradation time with respect to the target tissue, as well as appropriate biological functions in order to replace the damaged tissue in the osteochondral area. So this is my PhD topic. And after 4 years of the study, I got some publications and awards during my 4 years of PhD, which really grateful to my supervisors. Except for the publications and awards, I also had some talks during my PhD that my supervisors support me to go to other countries or in Spain or outside Spain to have some talks in the international conferences to introduce my PhD work. Also, I go to RCSI during my PhD for a secondment for around 3 months to enrich my research experience and also got the collaborations with this college. So yeah, it's also that now I work in this college. It's because I have the secondment and got the very deep collaborations with the supervisor here. So except for the academic things, we also have a lot of colorful life in IMDEA Material Institute. So the institute will hold some activities every year, like the Christmas party and some scientific activities. And also we have IMDEA Day. We will go out for traveling and then we can build up relationships with other colleagues inside your group or outside your group to try to get good relationships for collaborations. So I really had a very good life in IMDEA during my PhD. So here I'm going to share some experience about the PhD. So why do a PhD? Like before you do the PhD, you may ask yourself about these questions. So what I got from my PhD life is like, I think a PhD is not just a degree. It is also a way of thinking. So if you are curious about research questions and you want to develop the deep expert in a field, then you may choose a PhD to try to get a topic and then put your effort on this topic to try to solve the scientific problems. And I think the most important thing for a PhD is that you may gain the abilities of problem solving and independent thinking, which I think is not only important for your PhD, it's also important for your life. If you got the problem solving and independent thinking in your life, you may get better when you face challenges and problems. So why we choose IMDEA materials? So like Professor John Molina introduced before, we have very strong research environment. We have 19 research groups, which involved a lot of different topics. So why the research environment will help you? Because most of the PhD topic is multidisciplinary. So you may not just only focusing on one point. You may need to collaborate with other groups. You may need to learn a lot of new things. So in media, we have a lot of different research groups. You may talk to your colleagues like the PhD or the postdoc, even the PI. So you just knock the door of the PI office and you get in. They will try to help you with your research problems. And then we have very strong international and collaborative teams. So these are like some examples of the collaborators that we have. We met with a lot of companies, universities, and you can go to international collaborations with other people that you may help you with your future career. And then we have access to good facilities and projects. So here in IMDEA, you can meet a lot of international projects and work in very nice projects. And also we have a lot of fancy facilities that you can work with and trying to get a lot of scientific outcomes during your PhD. And the last point, which I think is really, really great, is like we have very great quality of work and life in Madrid. So here in IMDEA, we have very bright office, very huge office that you may can focus on your research, which I think this is the best office in the world. Um, then what makes a good PhD journey? From my point of view, I think maybe I wish I will know before my PhD starting. So it is normal to feel lost at the beginning. So when you got a PhD topic, you may say, "Oh, I don't know. I don't know what to do." It is very normal. It is normal to feel lost. You don't need to know everything before you're starting. This will gain from the learning process during your PhD. So asking for help is also a part of research. So ask the help for from your PI, your colleagues, the people around you. Even everyone in the institute will help you. And then everyone struggles and even experience researchers. So we will meet problems during the PhD, but it is normal. And you need to have confidence in yourself to meet these problems and think about how to solve it and ask the help from the people around you. And I think this is the thing that before we do a PhD that we should know. And what makes a good PhD journey that you should keep curiosity and motivation all the time. Because doing a PhD is it's not that easy. You may face a lot of problems, challenges in your life and in your work, and you need to always keep motivations on the scientific research. And then you should have persistence when things do not work. So it is quite normal. It happens like when the experiment didn't work well, you need to find out the problems and need to solve it. And so you should always keep persistence during your PhD and being open to feedbacks. So you may have like some talks or presentations with your PI, or you may present your things in the international conferences. You may get some feedback from your PI, your colleagues, or even some people outside the institute. You should be open for the feedbacks and trying to improve yourself and improve your research. So learning how to work independently. So I think for a PhD researcher, when you doing your PhD research, you need to keep independent thinking, because always when you got a topic, you need to know how to solve these problems. So doing research is a processing of found, found the problem and on the method to solve these problems. And I believe after the PhD degree, you may gain a lot of abilities about the independent thinking, and you may keep this through your whole life and trying to help you during your life. So progress in PhD is often slow, but it is real. So the persistence and independent thinking will help you throughout your PhD journey. And then I would like to give some final advice for all of you during your PhD. So don't wait to feel ready to do something. I know some people will say, like, before their PhD or during their PhD, they will ask themselves, like, do I'm ready? Am I ready for the PhD research? Am I ready for these things? So it is very normal, and it happens all the time during your PhD. You will feel like I don't know what to do. It's not clear situation, but it is okay. So don't wait for things to feel ready. You should keep courage during your PhD. And then choose a topic that you are curious about. That for me, I was working with the biomaterials, which I feel that I really want to know how to solve these kind of tissue defect. So I have passions, I have curiosities on my PhD topic, so that support me finish my PhD degree. And then talk to the people around or talk to the people in media and explore the opportunities. So I think it's good for you to ask for people and find opportunities that before your PhD that you may know more clear about what will you do during your PhD. And then enjoy the processing, not just the results. So during the PhD, you making a lot of abilities, like trying to solve the problems. You may got a lot of things, which is really helpful for your future, for your life and work. So it's not just only focusing on the research results. So a PhD is challenging, but also one of the most rewarding journey that you can take in your life. So I hope all of you can have a good time during your PhD, your future PhD life, and keep working on the researching. Yeah, that's all. Thank you.
So we're going to continue now with Dr. Isabel Gómez. Isabel was a doctoral student here at IMDEA Materials before going on to join our spin-off, Floatech. So she's still no longer at IMDEA Materials, but is just across the road from us here in Getafe. So Isabel, I will open the floor to you, and when you're ready.
Thank you, Andrew. Yes, I'm now working in Floatech, just in the building next door. So let me share my screen. Yeah, so I prepared these slides to share with you my experience just as Yuyao did. And I agree with everything that she said. So I hope this is not repetitive, but I think it's a common experience we had in IMDEA. And probably if you want to pursue a PhD in IMDEA, you will have a similar experience. So I think it's good for you to listen. So yeah, let's start. A little bit of my background. I'm from Guadalajara, Mexico. I studied chemical engineering there because I don't know, I like it engineering, I like it solving problems and a little bit of chemistry, but I didn't really I wasn't very sure about what I wanted to study, right? But then I had an exchange and like an academic exchange to Madrid, and I fell in love with the city, and then with material science. I got just one class, and I was like, wow, I really can like modify a material, the material's properties by changing something like very small, like a few atoms in the lattice, and it will change the whole properties of the materials. Or if you change the size of the material, it will change the property like the color or the flexibility or no, like, so I was very curious about this. So I started a master's here in Madrid, and I arrived to IMDEA doing first an internship, doing that master, and then doing my master thesis. And what I realized, it was like IMDEA is really a high level research center. We have cutting edge facilities, also international collaborations that make you feel like you are um, really like in the middle of the scientific conversation, like doing things that are really important. Um, a good thing also is that they have strong links with industry and with the, let's say, real world, because research is also the real world. I don't like thinking that only industry is what matters. But yeah, if you like that and if you like applied science, then in India you will find a lot of opportunities. The facility, once again, when I visited, John said it like, if you have the opportunity to visit IMDEA, it's really great to see all the microscopes, the labs. It's impressive, all the equipment that they have. and how easy it is to use it as a student. So yes, and also what I like the most is the international community there. The people working there, it's very collaborative. They are always willing to help. And so yeah, during these years, I found the most incredible people that are now my friends and my family. You know, coming from a different country, it's important to find a community. So IMDEA really uh, gave this to me. Uh, so I really enjoy it, and I think, of course, it's always changing because we are all only there for 4 years, or if you are doing only the master thesis, you are there for 1 year, 6 months. But the environment and the relationships, they stay. So that's why I decided to do my PhD in 2020 in the multifunctional nanocomposites group led by Juan José Vilatela, and I spent 4 years of my life doing that. So my project was about the synthesis of nanowires. We decided that nanowires were a good material to synthesize because they have all the advantages of the nanoscale. They have this high crystallinity, but they are also more stable mechanically. They have this feature that is one dimension is longer, so they have flexibility in that direction. They can have also anisotropy in other properties because of that difference in the dimensions. So it's a really interesting material. But what we wanted is not just to synthesize the nanowires, but synthesize them in a large scale to produce this network material like nanotextiles or like flexible electrodes that can work for energy storage, so batteries, or for catalysts, for water treatment. Imagine just cleaning your, having a filter made of nanowires and you clean the water, no? So yeah, having in mind this, all the applications that can come with having a material with the properties of the nanoscale, but in a macro format that you can actually touch and shape in the way that you want to use it. So nanowires, this is a little bit just of my project. And nanowires, how we synthesize it was with chemical vapor deposition. If you're not familiar, it's a method to grow materials that gives you high crystallinity. Normally, you use a substrate, you inject gases into a furnace, and with the heat, the material will deposit in that substrate to create a thin film, or as thin as you want. But if you, instead of using just the substrate, you use nanoparticles, metal nanoparticles, for example, gold, on top of it, the material will deposit only in those particles, and the nanowire will grow. So this is the traditional synthesis for nanowires with chemical vapor deposition, but we change a little bit something that is, instead of using a substrate, we use an aerosol of nanoparticles. So nanoparticles floating and flowing in a gas stream. In this way, instead of having to open the furnace and take out the substrate and put it again, and so on, we could just synthesize the nanowires continuously, and that allow us to have like more scalable process in case we wanted to scale it to industrial production. So another advantage that this method has is that you create in just one step without having to have a binder or glue to put together nanoparticles. The nanowires can entangle with each other like a spider web and create these paper-like materials. So here we have a paper made of carbon nanotubes or silicon nanowires. And as you can see, you can touch it, you can bend it, you can apply it directly to your device, but it's entirely made only of nanowires. So the name of this is floating catalyst chemical vapor deposition, and it works like this. A cool video to show you. So you inject the catalyst, the gas precursor to the reactor, they will react and alloy. Then in the hot zone, the nanowires grow, they get entangled, they mix together, what we call the self-assembly, and at the end you can extract the material like paper directly to the reactor in just one step. So I studied that method during my PhD with the idea of understanding if we could use it for more nanowires than just carbon nanotubes and silicon nanowires that were the ones that were already synthesized. So my job was to understand better the reaction and understand how we needed to tweak it to produce other materials different from those. So the first step was to build a reactor, the whole reactor with a lot of components and control and automation, and then start doing reactions. After having a synthesis, then I will take out a sample. I will characterize that sample and try to find a trend, a pattern that will tell me something about how the reaction was working. So, for example, understand why sometimes I will have nanowires and sometimes I will have only nanoparticles without the catalyst, or how I can lose the catalyst, or how can I contaminate it. And then based on that information, I will go back to the reactor, modify something to try to prove that hypothesis, let's say, and then do it again. Take more samples, characterize it, think, change something in the setup, and again and again and again. So it's just an iteration process. Of course, some of them work, but most of them they don't. So as Yuyao say, you need to enjoy the process, not only the results, because most of the results are not going to be the ones that you wanted. But at the end, at the very end, you will get what you wanted. So I was able to synthesize silicon carbide and tin oxide nanowires. And yes, the silicon carbide was just the first one to prove that it was possible to do something with more than one material, not just carbon and silicon, but the two together. And tin oxide nanowires were synthesizing, thinking on the application that was more about batteries. I saw a question about sodium ion batteries, and this one were used for that, but we didn't do it. We had a collaboration that tested them. So yes, during the PhD, I had the opportunity to write 3 papers related to those results. One for silicon carbide nanowires, where I studied all the reactor. Then one about like the theory behind the method with a review, and then one for the tin oxide nanowires that goes more deeply into how the reaction works. But also, I had other papers, 3 other papers from collaborations with other people in IMDEA or in my own group. Yes. For example, one about how to how to create those catalyst particles in the aerosol, in an aerosol. One about how the nanowires aggregate and shape this nanotextile, and another one is more about how to use those nanowires to create liquid crystals for different applications. So the science, let's say, it doesn't stay in your own project, but you will have also collaborations and you will have the opportunity to learn from other projects. And so basically what I want to say is that the main results are not the nanowires or the papers, but it's all the knowledge and the learning that I got. For example, well, it was a very multidisciplinary subject. I had the opportunity to learn about material science, aerosols, chemistry, flow dynamics. I used computational tools like Python programming, some computational fluid dynamics simulations. I also learned how to control and automate a chemical process. Also, of course, the characterization of the nanowires. I use a lot of resources from IMDEA. The TEM, the SEM microscopy, Raman, X-ray diffraction, gas chromatography, and all of that. During these 4 years, I had to learn the technique, learn how to analyze the results, and then how to extract a conclusion from them. Also, during the writing of the publications, you learn a lot. I even had the opportunity to patent one of the processes, and so yeah, that was exciting. And the most important is the human skills, as you also say, the problem solving that you gain, the problem solving skills that you gain are important because you face a lot of problems and you need to find a solution. Also, you gain a lot of autonomy as a researcher because it's not only doing what someone says that you need to do, it's about what you think is best. And then, of course, always ask your supervisor, always ask the opinion of other colleagues, and in contrast if you think you're in the correct path. But that will give you like self-confidence as a researcher. You learn how to plan as well, how to design experiments more efficiently. And of course, you will gain a lot of patience for the bad results. So other experience that I have, I also did a 3-month secondment in Cambridge, University of Cambridge. I went there to do experiments and to simulate the nanowire agglomeration for that paper that I mentioned before. And it was a really nice experience. First, to just live in another place for 3 months, knowing that I will come back to home. And also to be in an university that is well known and it's like top university, but realizing that it's just like another university and it works very similarly to the universities that I know here in Spain, and that they are also doing research as we do. So yeah, it was great to collaborate with them and see the human part of the Cambridge University. I also went to conferences that allows me to go to different places, to France, here in Spain, in Germany, and present my work. The conferences are not only to like show off your results, are more, I think, about listening what the community is doing and try to find the possible collaborations or see like, okay, I'm doing this, they are doing that, and maybe I was not thinking about how something that's another group in another country is doing regarding, I don't know, materials in health can help me to do materials in energy. So yeah, it's very rewarding. And now I I work in Floatech. Floatech is a spin-off company of IMDEA Materials. This means that well, it is a startup that I started in 2021, from a PhD just like mine, but from uh, the guy that did it just before me, my friend Richard, and him with my supervisor. They founded this spin-off. They use the same method, the floating catalyst chemical vapor deposition, to produce silicon nanowires and use them for lithium-ion battery anodes that are 100% silicon. So that means they will have higher capacity than graphite, and also longer lifespan because of the nanowire. They can withstand better the change of volume that comes with lithiation of the silicon. So in 2024, they opened a new pilot plant facility, the one that I'm in right now, just next to IMDEA. And last year, when I finished my PhD, they hired me to help them with the scale up of this process, thinking that I was doing during my PhD about like producing milligrams per hour of nanowires, and now we need to change that for tons per year. So it's a big challenge, and now we are working hard on it to achieve it. Just to end my presentation, I just wanted to say that doing a PhD is challenging, but it's transformative. You enter being a student, and during the PhD, you can have the confidence that you will learn a lot. And also, as Yuyao said, you don't need to be ready, because the PhD is what will make you to be ready to be a researcher. IMDEA provided a perfect environment to grow, and that the skills I gained allowed me to have this job that I have. And I think regardless if you choose to continue in academia or go to industry, the PhD will give you skills that will help you in life, whatever it is. And thank you. And if you have any question about this or anything, you can send me a mail or find me in LinkedIn.
We're going to move on to our final speaker, which is Professor Javier Llorca, who is our scientific director. He is also the head of our biomechanics of materials research group here. He is a recipient of the National Research Prize Leonardo Torres Quevedo in engineering and architecture, and also recipient of the Miguel Catalan Research Prize here in the community of Madrid. So let me bring in Javier, and then we will go into some final questions. Javier, I open the floor to you.
So as Andrew said, my name is Javier Llorca. I'm the scientific director of the Institute, and I'm going to share with you now several current proposals of PhD topics that are currently open in the Institute to carry out the PhD in different lines. Just to let you know before this that if you are interested in doing PhD in a specific topic, I mean, there is plenty of information in the webpage of the Institute, and basically you can go through the different PIs and the web pages of the different PIs. And if you find an area or person or a topic that you really resonate with, just contact them directly and say, okay, I would like to do a PhD in this and that, and let's explore what are the funding opportunities for a PhD, either through fellowships or perhaps there is a project that can support you. So we are pretty open. And of course, we are hiring people from all over the world. Currently, the Institute holds people from 24 or 25 different nationalities. So that's very international. And nobody cares where you come from. Insofar you are able to speak a decent English, so basically to communicate and to work here. So being said this, I'm going to share my screen, and I'm going to share 5 topics that are currently available for a PhD. If you are interested in any one of these topics, you will see that in the top right, there is a thesis topic 1 or topic 2. So when finish the presentation, send an email to Andrew telling him I am interested in thesis topic 1, 3, or 4, or whatever. So he can basically contact make you contact with the appropriate PI. So the first one deals with laser-powered perfusion of complex shaped metallic glass components for energy-efficient motors. The idea is very simple. I mean, there are 8 billion of electric motors operating in the US. Of course, you transform, direct current into an alternating movement through a magnet. The energy losses in the magnet are equivalent to 30% of the all energy consumed in Spain in 1 year. So the objective of this project is to develop new electric motors with higher efficiency by replacing the steel rotor and stator components by iron metallic glasses that are manufactured by laser power both fusion. The main advantage of that, as you can see in the figure, is not only that the losses are small, but also, as you can see here, you can print the whole rotor in one shot by 3D printing, and you replace this one shot by many, many different parts that have to be assembled. So that's a very, very interesting topic. The expertise required for the PhD is a master in metallurgy or material science, and of course, previous experience in physical metallurgy will be valued. Then the skills that you will acquire during the PhD are in the area of additive manufacture by laser power fusion, microstructural characterization, and characterization of mechanical and magnetic properties. At the end of the PhD, basically you would be a good material scientist with a knowledge between processing, microstructure, and mechanical and magnetic properties of metallic glasses that have been manufactured by additive manufacturing. And this project is carried out in collaboration with another university in Spain, Rey Juan Carlos, as well as with the Technical University of Berlin and the Italian National Institute of Metrology in Italy. So basically that allows that very likely you will be able to do a secondment either in Madrid, another university, or in Berlin or in Italy, and learn more skills and also work in a different environment. The second thesis topic deals with fire-safe materials for energy storage, and in particularly for batteries. As you know, batteries are used widely and more widely in many, many different applications. And one of the main problems of batteries is that they have a shortcut, they may go into fire. So developing fire safety materials for the encasement of batteries is a crucial topic in many applications, including transportation, electronics, and construction. And this is basically the main goal of this thesis. The expertise required is a master in science in chemistry of material science. The skills that you will acquire during the PhD are fundamental understanding on electrochemistry and how chemistry and basically batteries are related to fire testing, and also learning how to do flame retardant synthesis of nanomaterials, and of course fire tests are the ones that you have here, where you really burn things and see how good they are. And the expected progress beyond the state of the art in the thesis is to develop the next generation of fire-resistant polymer-based composites that can be processed easily, that are recyclable, and they are an alternative to the current encasing of batteries that use aluminum because of fire safety problems. This thesis will be carried out in collaboration with a leading research center and a leading company in the fields. So basically, you will have a very close contact with the applications in industry of the new materials that are developed within this topic. The thesis topic number 3 is crystal control in synthesis of nanowires for energy. And I would say this is somehow a follow-up of the thesis that was presented before. Basically, the thesis is at the interface between nanomaterial synthesis and the assembly of electrodes for energy. And the basic idea is to explore different routes to grow new materials, nanowires, nanotubes of different metals or metal oxides that can be used for electrodes, for energy, and for batteries. The expertise that is required is a master's degree related in inorganic chemistry, nanofabrication, material science, chemical engineering, or applied physics. So, it's very, very wide, the idea. And the skills that you will acquire during the PhD are the design and use of gas phase reactors for synthesis of nanomaterials with crystal control. You will learn a lot about characterization of nanomaterials including spectroscopy, aerosol methods, X-ray diffraction, electron microscopy, and of course, electrochemical measurements. And you will also learn how from these materials to prepare electrodes for batteries. We will model batteries to see how good they are. This is a very, very fundamental PhD where the main aim is to understand process of nanowire growth by studying the sequential reactions, the alloy formation, the crystal nucleation, the layer growth for different chemistries. And they include silicon, silicon carbide, and many different metal oxides. And you will learn how to control the nanowire structure from the project by tuning the processing parameters, and very likely trying to go into new chemistries and new nanowires by doping and by changing the parameters. And this project is funded by a grant of the European Research Council, so it will be plenty of room for very, very fundamental research. And of course, the group has a lot of collaborations with national and international groups, so it's very likely that stages in different places throughout Europe or in the US can be arranged. The thesis topic number 4 is a follow-up of this, is in the same group, and this has something that is basically more related to the Floatech spin-off, and is related to the carbon nanotubes for power electronics. So the PhD is at the interface between nanomaterials and power electronics. The expertise that is required is a master's degree in material science, nanofabrication, and applied physics. The skills that are required are the characterization of carbon nanotubes that have been manufactured by floating catalyst process. And what is more important, the processing and integration of these carbon nanotubes into devices, materials that are used in power electronics. And the overall objectives of the PhD is to develop a route to introduce and recycle carbon nanotubes conductors for power electronics applications. So this will lead to a reduction in weight. This will lead to a new method to remove the carbon nanotubes without changing the chemical properties and the crystal structure, and to reroute these carbon nanotubes to integration as conductor in power electronics devices and do full recycling. This is a PhD in a new European Marie Curie doctoral network. So basically you will be able to interact with many other PhD students working in different labs throughout Europe that are working on different parts on this area of basically power electronics. And of course, this will secure internships in various European laboratories during your PhD. And last but not least, there is an autonomous laboratory for polymer and polymer composites. So, there are polymer and polymer nanocomposites are used in many, many different technologies, but normally the technologies to develop new materials are based on a trial and error approach, and this is very time consuming. In the last 2 or 3 years in IMDEA, we have developed, you can see the picture here, basically an automated laboratory where robots are able to process the material, to characterize the materials, and to obtain the microstructure and the mechanical properties, so they can work 24/7. And we also use artificial intelligence tools and Bayesian optimization algorithms to teach the robots what are the next steps they have to do in order to design materials with optimized properties. So there is a very large group of people working onto that. The idea is to incorporate more PhD students. The progress beyond the state of the art is that you will be involved in a fully autonomous experimental platform in which robotic systems execute experiments while artificial intelligence algorithms will dynamically select and prioritize the next experiments to perform. And this is really state of the art in experimentation. And the expertise is very varied because you can participate in this initiative in many different sections. So you would either a master in material science and chemistry and physics, or in computer-related discipline to write the artificial intelligence algorithm will be basically useful. Basically, you will acquire skills in what is the next frontier in experiments that are laboratory automation, machine learning, and in this particular project in polymer science. And then finally, the last project is a very computational project that has to deal with the use of first principles calculations to design phase diagrams of metallic alloys, including the effect of strains. As you probably know, if you have expertise in material science, phase diagrams are the building block to design new metallic alloys for engineering application because they provide all the information about the stable and metastable phases and solubility limits. We are exploring the modification of these phase diagrams using elastic strains. This can be done by using either epitaxial growth or hydrostatic stresses. And if you change the phase diagram, basically you are able to design new alloys. The idea is basically to do this using computational tools. And basically you see to the right, basically in black in the figure is the standard, basically accepted phase diagram for cobalt aluminum. And what you can see here in red are the predictions that you can get using first principles calculations. So we're able to do very, very accurate predictions. So the expertise that is required for the PhD is a master in physics, metallurgy, and material science, and of course, previous experience in first principles calculations or simulation in material science will be valued. The skills you will master the application of first principles calculation and statistical mechanics in material science. And basically, what is the expected progress beyond the state of the art is development of high throughput strategy to predict phase diagrams of binary metallic alloys, including the effect of elastic strains. This thesis will be carried out in collaboration with a university in China within the framework of a bilateral project. And the PhD student will be eligible for a 6-month stay in China. So if you want to go to China, this is your project. And these are the projects that are available at this point. But as I told you before, if you are interested in other topics, just check the web pages of the principal investigators. And if there is a principal investigator that you really would like to work with because his or her skills or basically the topic, just contact him, her directly. That's all. I'm open to answer any questions that you may wish.
Thank you very much, Javier, for that. Yeah, just to reiterate, there were a couple of questions that just came through with regards to whether we could provide a thesis topic list. Just a reminder that when these positions are available, they are all listed on our career opportunities page. You have the link there in the chat, and there you can find specific admission requirements, because obviously each position, the admission requirements are going to be a little bit different, but the admission requirements for each position are outlined on our career opportunities page. Javier, this one maybe for you or for John. Just I think one important question that's come through from the chat so far, and then we'll get through to any additional questions. Kind of putting a few questions together, we had from Abdullah, have applied for 2 projects, but was rejected. I want to know specifically about the selection criteria, a roadmap for PhD admission. From Haider, please share the way to get a PhD at IMDEA, the requirements. So I guess either Javier or John, maybe if you can just give a bit of an overview here as to the roadmap or the procedures that go into actually being admitted to being able to do a PhD here within their materials.
Well, I can answer, I can take that. So IMDEA is not a degree granting institution. So people that carry out the PhD at IMDEA, they are registered in one university, and this is the university that provides the PhD diploma. Most of the people, 90% of the people that get the PhD in IMDEA are registered in one of the universities in Madrid, either the Polytechnic University, the Carlos III University, the Rey Juan Carlos University, the Autonomous University. And in order to join this PhD program, in order to get the diploma, there are some minimum requirements. The most typical minimum requirement is that you need to have a master. So you have to have not only a basic, but you have to have a master. And of course, if you are doing a master in IMDEA, normally the master will be material science, physics, chemistry, materials engineering, topic related to that. So this is what I would say is the legal or fundamental requirement that you need for that. On top of that, you have to be admitted in IMDEA. And in order to be admitted in IMDEA, basically one of the principal investigators of IMDEA has to admit you and basically to be your advisor and to decide to be your advisor. And this is basically the most critical part of the process. So when there are applications, there are positions open in the PhD, that basically you can apply for that, and if you are selected, you are selected. And that's it.
Yes, just to add to that, specifically for Abdullah's question, when we have these offers published in the webpage and the applications are opened, we many times get more than 100 applications. So we have an evaluation panel for each of these one open positions that evaluates all the applications, does a screening, preselection, and interviews the most interesting candidates. It's all based on merit, okay? So I'm sorry that you went through the process of rejection. My only advice to you would be to keep trying, okay? Just apply for the positions, and then the other way in which you can be admitted is, as Javier was saying, if you are interested in a particular topic or a particular principal investigator, feel free to contact them and see and explore the possibilities of doing a PhD.
Thank you, Javier and John. Hopefully for Haider and Abdullah, that answers your questions there. Lucas, you had your hand up, so you have a specific question that you'd like to ask?
Yes. Thank you, everybody, for their presentations. It's just about how strict are the master studies prerequisites? Because in my personal case, I'm studying a master's in engineering, so they're a bit more broader. It's not a master in physics or, for example, metallurgy. But if I'm still interested in a PhD topic, are they very strict? Should I get a master's in metallurgy? That's sort of my question. Thank you.
Not necessarily, Lucas. Depends on the topic. The topic establishes the requirements, and as you could see in the list of examples that Javier mentioned, most of the topics are very multidisciplinary. So most of them would fit with a master in engineering. So the master requirement is more related to being admitted in a PhD program, okay? And as far as your master together with your bachelor fulfills the requirements to be admitted in the PhD program, if it is aligned with the topic of the PhD, there should not be any limitation.
Thank you.
Thank you, John. Francis, I think you had a question as well, and then we'll take another question from Abdullah.
Yeah, I have a question. I would like to know when this positions are starting, because I recently had an interview for one MDR project, but the project was starting in June, so I had to let go. I already have a master in material science, and I'm completing a second master in Erasmus program, which we will complete in the earliest is 10th September. So I would like to know when most of these projects are starting.
That's something I'm afraid it will depend on the position. I mean, some positions have a linked and a starting date because of the project that is funding the position starting in a given date, and others have a longer possibility of incorporation. But I'm afraid this will depend a lot on the position, on the specific position.
Okay, thank you very much.
Thank you, Francis. And Abdullah, you had a follow-up question there as well?
Yeah, thank you so much for the presentation and giving me the opportunity to question. My question was that as I have done master's research in nanomaterials and developing polymeric membranes for wastewater treatment, and I want to pursue my PhD in batteries and electrode materials. So having not the prior experience in batteries, can I still be eligible for the projects that are announced in these fields? Or should I have some prior experience or something, publications like that?
Again, I mean, I think our alumni gave a very good summary of what you should have before starting the PhD. So the answer is this is not a prerequisite in the sense that the PhD is a learning process. But of course, in the application process, everything counts, and the merits that you have will be compared to the merits of other applicants. So anything that you can do to improve your CV in the area in which you are interested will help on the admission process, for sure, in the selection process. But it's not a prerequisite. I don't know whether Javier wants to add anything on that, but
No,
mhm.
no.
Andrew, are you talking because we are not listening to you?
Sorry, I knew it would happen, at least one. Just one question that I thought was relevant from Fatima in the chat. She was asking about internship opportunities
Yes.
because she's interested in possibly gaining some experience before doing a PhD, which sounds like quite a reasonable idea. Can you maybe touch on that, John?
Yeah. We have not every year, and to be honest, it's not decided yet whether this year will be this call or not. It will be decided this month and published in May. But we have regularly research initiation fellowships. So these are fellowships that are actually fulfilling this interest that they were showing on having a 3-month experience of research in the institute in order to be prepared later for a PhD. As I said, this year we don't know whether there will be this call. If there is, it will be published in May. So I would suggest that you keep track on the webpage because it will be announced. But independently of the call, we regularly host intern students in the institute. And the best way of finding internship opportunities is, again, to contact the principal investigator or the research group you are interested in. And then they will tell you whether they are able to offer you any internship or not. It will depend on the projects that are active at each time and the possibilities that each group has. So I insist. Sometimes we have these calls, and if we have this year, it will be published in May. So look at it. But again, contact any principal investigator you might be interested in because they might have internships to offer.
Thank you very much, John. I think we are going to have to wrap up because we're already over time. We maybe can go until 11:30. So just 2 rapid-fire questions for you, John, before we finish. From Akshay asked, is there any possibility to extend PhD funding beyond the initial duration if needed to complete the thesis?
Yes, I mean, again, these type of questions are very specific and dependent on the actual fellowship or project in which you are working. At the end, the minimum time requirement for a PhD are 3 years. Depending on the fellowship, sometimes your own fellowship has funding up to 4 years. And other projects also, depends on the duration of the project, might have funding for 3 or 4 years. Having said this, the reality is that in our experience, a PhD typically lasts between 3 and 4 years. So it's very few PhD students that finish their PhD in 3 years. And the institute typically tries to support, but again, this depends a lot on the specific case and the specific project, so that the student has time to finish before the 4th year limit. Okay, so the answer would be in general, yes. Okay, the institute supports, but most fellowships already give funding for 4 years.
Thanks, John. Just to follow up and question on that one, or a related question, from Haider here, do we get funding from IMDEA or from the university? Can we apply directly at IMDEA without getting admission at a university?
Okay, so this is very much related to what Javier was explaining. We are not an academic institution. So what we are offering here is the possibility of carrying out the research project, a PhD research project with us, okay? So we open all these positions, so we have different possibilities. If you are interested on doing a PhD with us, we can apply for a fellowship together. So the funding has to be either supplied by a fellowship that you apply to together with the institute, or through a research project that is already funded in the institute and requires the PhD position to finalize the project. And in parallel, you would request the admission to university, okay? But the funding, I insist, is either coming from an open project that is already funded in the institute and is looking for a PhD candidate to fulfill the project, or the other alternative, if you are interested in doing a PhD with us, you can contact the principal investigator, and depending on the case, we can try to help you request a fellowship that will provide the funding to do the PhD with us.
Perfect. Okay, well, we are right on 11:30, so we will have to wrap it up there. Okay, I'd like to thank everybody for joining us.